Hello class, let's discuss shear strength of soil. But here in this lecture, we will focus more on direct shear test. So first, let's define what is shear strength. I know you're familiar with shear stress. The shear strength, particularly in a soil mass, is the internal resistance per unit area that the soil mass can offer to resist failure and sliding among any plane inside it. So uh, these are the type of failures due to shear stress. So we have here landslides. So that's a shear stress is or the shear strength of the soil is a major factor on which this phenomena happens. Okay, so from the definition itself, uh, it is the failure and sliding along any planes inside a soil mass. So there is sliding that happens in the soil mass. The same way with structures that are built sa soil. So there is also an effect if that soil has a low bearing capacity. So shear stress again is a major factor on which structure will fail due to the bearing capacity. So again, shearing stress pa rin ang magte-take effect sa soil. So magkakaroon ng sliding dun sa surface or dun sa underneath ng ating structure. So hindi man na-compress yung soil, so depending again on the type of soil where the structure is built. So if that failed due to bearing capacity, there is again a tendency that there is a sliding on the surface on the soil mass. So here's an example of bearing capacity failure. So again, shear stress failure siya. So uh, yun nga, nag-tilt tong building dahil nagkaroon ng sliding dun sa soil mass underneath this structure. So significance of shear strength. Engineers must understand the nature of shearing resistance in order to analyze soil stability, okay, such as the bearing capacity, slope stability, and the lateral earth pressure on retaining structure. So, napakahalaga na maintindihan natin ang concept na meron sa shear strength kasi it is essential sa paghahanap ng bearing capacity, ng slope stability, and sa pag-design ng mga earth retaining structures. Okay? So, kasama din yung pavement. Shear strength on soils. The shear strength of a soil is its resistance to shearing stress. So, yun nga, if we have force applied on an object that causes a plane that is parallel to these forces to slide. So, yung area na yon na kung saan parallel dun sa force, yun yung under sa shear stress. So, ganun din sa isang soil mass. So, if this is a soil mass, so the ability of the soil to resist shear stress is your shear strength. Then it is a measure of soil resistance to deformation by continuous displacement of its individual soil particles. Shear strength in soils depend primarily on interactions between particles, and shear failure occurs when the stresses between the particles are such that they slide or roll past. So as you can see here on this figure, so the shear strength depends primarily on the interactions between the particles. So say this is the soil particles, so there is interaction between soil particles. But if it reaches the maximum shear strength or the shear force applied on this soil, so shear failure may occur, and when the stresses between the particles are such that they slide or roll past each other. So means that they will slide on each other. opposite direction yung ating soil mass. So para magkakaroon ng layer between the soil mass na kung saan magi-slide na yung ating magi-slide or mahahati yung ating soil mass. Okay? So, soil derives its shear strength from two sources. Una, sa cohesion between the particles. It's the cementation between sand grains, electrostatic attraction between clay particles. So, cohesion. Second one is the frictional resistance between particles or stress-dependent component. So again, due to cohesion and frictional resistance. Measure of the forces that cement particles. So parang when we say cohesion, it is the ability of material of the same material to stick with or the particles to stick with each other. So usually ang mga example of type of soil na kapag sinabi kasi natin cohesive, parang medyo madikit na material yan. So they have the ability to stick with each or of the same material to stick with each other. So ito ang mga example, dry sand with no cementation, dry sand with some cementations of clay. Then we have stiff clay. So cohesion contributes in the shear strength of soil. The second one is the internal friction angle or the friction between the particles, okay, when subjected to shear stress or shear stress. So our symbol used for the internal friction is phi, and we express that in angle, okay, in degrees. So Moore in 1900 presented a theory of rupture in materials that contended the material fails because of a critical combination of normal stress and shearing stress, and not from their maximum normal and shear stress alone. So, as we recall, normal stress, a force applied perpendicular to a certain area. So, dito sa normal stress, usually yung sa in situ stress na topic natin. So, yung pagkuha nun, yun yung magagamit natin sa paghanap ng normal stress sa isang soil at any depth. And we have shearing stress. Okay? So, to determine the maximum strength of a soil, it says here, according to Moore, it is a combination of normal and shear stress. Okay? So, later, we will discuss that using the Moore circle or the theorem introduced by Moore that we will use Moore circle in computing the maximum strength of the soil given that we have a maximum shear and maximum normal stress on the soil. So here in this lecture, we will just focus only on shear stress. So here's the general equation for shear failure. We have a function of sigma or a function of the normal stress. So for most soil mechanics problems, it is sufficient to approximate the shear stress on the failure plane as a linear function of normal stress. So we can rewrite that as, since we will express the shear strength or shear failure as a function of normal strength, normal stress. So if we have a cohesion, okay, if we have a cohesion, we will add sigma or the normal stress tangent phi for the angle of friction. So again, this is another general equation for computing the shear failure. So phi is angle of internal friction, sigma is normal stress on the failure plane, and we have the shear strength, sigma tau f. Okay, so in saturated soil, the normal stress at a point is just the sum of the effective stress and the pore water pressure. So if we are required to determine the effective stress, or if we are required to determine the shear strength of the soil with regards to the effective stress of the soil, so our solution is just take the effective stress, effective cohesion, okay, the cohesion of the soil, and same solution, sigma prime is just the effective stress of the soil, tangent phi, or the friction again. Okay, so here are the typical values of drained angles of friction for sands and silts. So usually these are the values of angle of internal friction, but in some problems we compute these values. Okay, so here is an example of plotting the the normal and shear stress on a soil. So usually we assign the values for normal stress on a graph along the x direction, x-axis. We use normal stress, and along the y direction, y coordinates, we use shear stress. So in order for us to locate the point at which the strength of the soil on a certain plane shall be determined. So, later, madidiscuss natin yan sa triaxial test. But here, the inclination of the plane failure caused by shear. So again, this is more circle. We will apply more circle in determining the, the values required on the soil. So we'll just discuss this later on triaxial test lecture. Okay, when we will use more circle in determining the shear stress at failure, normal stress at failure plane, and any values, other values. Okay, so let's skip this first. Okay, so laboratory test for determination of shear strength parameters. So we have two types of tests. We have the direct shear test and the triaxial shear test. So these tests are used in determining the shear strength of a soil mass. So here, let's discuss direct shear test. So direct shear test is a quick and inexpensive way of determining the shear strength of soil. Shortcoming is that it fills the soil on a designated plane, which may not be weakest one. So, used to determine the shear strength of both cohesive as well as non-cohesive soil. So, yun lang ang disadvantage of direct shear test, is that it fails the soil on a designated plane only, which may not be the weakest one. So, there is a slight inaccuracy sa paggamit ng direct shear test, unlike dun sa triaxial. Again, this is the fastest way of determining the shear strength of soil. So the test equipment consists of a metal box in which the soil specimen is placed, and then the box is split horizontally into two halves. So let's say this one, this figure, that's your metal box. You put the soil, then there is a shear stress applied on the soil. So that's it. You will be able to determine the shear strength of the soil. Okay, so shear force is applied by moving one half of the box relative to the other to cause failure on the soil specimen. So these are the direct shear test apparatus. So this one we have here on CSPC, this type of apparatus, the direct shear test apparatus. Okay, so again, same procedure. So you put on the metal box the soil, then apply shear force, a predetermined shear force, and from that we will be able to determine the shear strength of the soil. So there are many trials that the direct shear tests are repeated on similar specimen at a various normal stress. So varying if predetermined normal stress is applied to the soil. So marami tayong trials na gagawin dun sa soil mass. Then hinahanap natin yung normal stress and shear stress dun sa soil na yun. Then we can now plot the points kung saan yung location ng normal stress at shear stress dun sa trials na yun. And after plotting those points, so we will draw a best fit line that is close enough to traject yung points na na-plot natin dun sa mga trials sa direct shear test. So from that, we will be able to determine the angle of internal friction of the soil. So, ang angle of internal friction kasi class, mahalaga siyang property ng soil na dapat nating mahanap. Okay? Kasi necessary siya sa pag-design ng mga structures, mga retaining structures. Sample problem. The direct shear tests were performed on a dry sandy soil. The specimen is 50 mm in diameter and 25 mm in height. Test results were as follows. Determine the cohesion and angle of internal friction. So let's say we have given here the normal force and shear force. So the mold for the direct shear test is a cylindrical type of mold because we have here diameter of 50 mm and height of 25 mm. So again, if this is subjected to normal force, so our area is this one. The same with shear force, the area should be parallel to that force. So this area here, so our area is pi r squared, or we have a diameter 50 mm. So pi d squared over 4. So substitute lang natin yung d. So convert that to meter. That's 0.05 meter raised to 2 divided by 4. So pi r squared 0.5 squared over 0.05 over 4. So that's area is 0.00196 square meter. Very small. So let's store that in A. Okay. So to determine the normal stress, so normal stress is just force over area. Okay, force over area, the normal force, which is this one. So to determine the shear stress, I will just show it on the calculator. Our area is A. I assigned it in A. So we have 243 over area. Okay, force over area. So our unit here is in Newton per meter squared. So that's in Pascal. So this is 123,758.88 Pascal. So divide this by 1,000. So if we divide this by 1,000, the unit becomes kilopascal. So that's 123.758. Okay, or 123.8. So next, for the shear stress, same area, just change the shear force. So force over area again, we have 63.1. Next, 268, we have 136. Okay, then 137, 69, 77, 69.8. Then we have 352 equals 179. So that's the answer. Okay. And 179 shear force divided by area, shear stress is 91.2. Next, 412, 209.8, then 210. Okay, so 106.95. Okay, so these are the values of your normal stress and shear stress. So we will use these values for trial 1, 2, 3, and 4 in plotting the normal and shear stress points, okay, on this trial. So again, how do we plot this? Going back on this lecture. Okay, so balik. Okay, so yan. So ipa-plot lang natin, class, yung mga points na yon dito sa more space. So paano ba mahanap yung ating internal friction and cohesion? So when a soil has no cohesion, so kung magpa-plot na tayo ng best fit line dun sa points ng ating normal and shear stress, say for example, ito yung na-plot nating line nung kinonect natin, or gumawa tayo ng best fit line dun sa points na ginawa natin. So, if at zero normal stress class, na-intersect niya yung y-axis, at merong value tayo ng shear stress dyan, ibig sabihin, yung value na yon at zero normal stress ay yung ating cohesion. Okay? So, cohesion yan. Kapag in-intersect niya, yung best fit line na drawing natin gamit yung mga points, na kung saan at zero normal stress ay may value tayo ng y value. Okay? So, ibig sabihin, may cohesion yung soil. Cohesive yung soil. So, the same way, kapag sa paghanap naman ng internal friction, it is measured from the horizontal. So, kung ito yung line natin, so, kukunin lang natin itong angle na mapo-form from the x-axis or from the horizontal papunta dun sa line na yun. So, yun na yung ating angle of internal friction. So, kung ang soil ay hindi cohesive, wala siyang cohesion, so ang drawing niyan ng line na mapo-form natin ay i-intersect niya lang naman yung ating origin. So, ibig sabihin, at zero normal stress, zero din yung kanyang shear stress. So, again, the value of cohesion is that if the normal stress is zero tapos may value, ang ating cohesion, which is greater than 0, okay, ibig sabihin, cohesive yung soil. But if the normal stress at 0 is, and the shear stress is equals to 0, so ibig sabihin wala tayong cohesion. So again, going back dun sa sample problem natin, kung ipa-plot natin to, yung 0.1, 123.8, and 63.1, so, yung test 1 ay nandito. So, let's say yan, 123.1 and 63.1. Okay? Yung kanyang y value. For test 2, 136.5, 69.8. 136.5, 69.8. So, the same with test 3, test 4. So, again, if we already have these points, just plot the best fit straight line between these points. Okay? At ang line na yon ay ito. Okay? So base pa lang dito sa drawing ng line na na-form natin, So, na-intersect niya yung point of origin or the normal stress is 0 and shear stress natin ay 0. Ibig sabihin, since isa nga sa required natin ay yung cohesion, the cohesion here is 0. Okay? Next, for the angle of internal friction, to compute the angle of internal friction, so we will just use that or we will just make a triangle a right triangle that can be formed by this line here. So, since na-hit naman niya nung line natin lahat ng points, we can just select at any point dito sa mga test natin. So, let's say, pinili kong point ay ito na tinamaan talaga nung best fit line na drawing natin. So, say this itong triangle na to. Say this triangle here. So, dun tayo nag-ano sa test 3. Okay? So, the values for normal stress is 179.3 and 91.2. So, 91.2 siya. So, kung 91.2 ay ito yung vertical distance niya at yung 179.3 ay yung horizontal distance nito galing dun sa origin. So, base dito sa na-form natin na right triangle, okay, we can just use tangent function. Okay, tangent function, tangent phi equals to opposite over adjacent. 91.2 over 179.3. So, ibig sabihin class, phi is equals to arctangent of 91.2 over 179.3. So, ating angle of internal friction ay tangent 91.2 179.3. Okay. So, the angle of internal friction is 26.96 degrees. That's the answer. Okay, we have 0, cohesion, and an angle of internal friction of 26.96. Okay, that's how we solve a problem in direct shear test. Next problem. A direct shear test is performed on a specimen of dry sand. The shear box is circular in cross-section and the diameter of 50 mm. Again, the normal force is imposed on the specimen with 250 newtons. The shear stress when the shear force is 150 newtons. Determine the angle of internal friction. So here, there is only one trial applied on the direct shear test. So that's enough to determine the shear strength and the normal strength of the soil, as well as we can also determine its angle of internal friction. So let's solve this. So let's compute now the area, cross-sectional area, given we have 50 mm diameter. So convert that to meter first. We have 0.05 meters square over 4. So pi d square over 4 is equals to 0.001963 square meter. So the normal stress is equals to force over area. Normal force 250 newtons over the area of 0.001963. The answer is, so I will just store this to A so that we have an exact answer. 250 over the area, 127,323 newtons. So kung i-convert natin sa kilonewtons, divide lang natin na 1,000 to. So, sulat ko muna, 1,027, 323.95 newtons. Or, in kilonewton, divide by 1,000, 27.324 kilo Pascal. So, this is in square meter, Newton per square meter. That's in Pascal. Or divide 1,000, turns out to be kilopascal. So for the shear stress, we have shear force over area. So we have 150 newtons over the area, 0.01963 square meter. So we have 150 divided by area, 76,394.37 Pascal, or 76.394 kilopascal. So, yan yung sagot sa normal stress at shear stress. So, how do we plot this? Okay. So, if we are going to plot the point of normal stress of 127.324 and 76.394, so we have 127.324, let's say it's right here, and 76.394. Okay, so the location of that point is right here. Then it does not mention in the problem to find the cohesion, and since we only have one trial, we assume here that there's no cohesion. Okay, we have zero cohesion here. So we will just connect that to the origin where we have zero normal stress and zero shear stress. So we can now identify the angle of internal friction. So again, this vertical distance here is 76.394 and our horizontal distance is 127.324. So to compute the angle of internal friction, use tangent function and take the ratio of the opposite 76.394 over 127.324, or phi is arctangent of 76.394 kilopascal over 127.324 kilopascals. Cancelled out the unit kilopascal. We have a unit of degrees. So let's compute that. Arctangent 76.394 over 127.324. So the answer is 30.964 degrees. That's the answer for the angle of internal friction. Okay. So next, the following are the results of direct shear test performed on two identical samples of the soil. In test 1, the sample sheared at a stress of 71 kilopascal when the compressive normal stress is 95. In test 2, the sample shear is 104 and the normal stress is 150 kilopascal. Determine the cohesion, angle of internal friction, and determine the shear stress at a depth 4 meters if the unit weight of the soil is 15.6 kilonewtons per cubic meter. So let's solve this problem. So let's say we make a table for the test number and its corresponding normal stress and shear stress. Now, if we are going to plot the best fit line for these values, so if we already locate that test 1, which is right here, test 2 here, locating the points, So if we are going to draw a line between these 2 points and extending it, okay, so we might have a value of cohesion. So if there are two or more values or two or more tests, there's a chance that we have a cohesion value here. But if the drawing that we make, when we make a straight line, when drawing a best fit line for the points of each trial, and when it intersects the y-axis at which the normal stress is 0, so if there is a value for the shear stress there, there is a cohesion. So here, we will not use the graphical solution, or we'll just estimate the value here for the cohesion. Pero instead, we will compute the value for cohesion since we have the data. Okay, so the best solution in computing the cohesion is that we will interpolate. Okay, we will interpolate, which means that we will take the ratio of the highest point. Okay, we will take the ratio of the differences of the vertical distance of a triangle form between these 2 points right here. Okay, so kunin natin yung ratio ng vertical distance niya. Let's say ito, y1, x1. And yung point kung saan tumama na dun sa y-axis. So we can form another right triangle there. So the total vertical x2. Okay? So if we will form right triangles here, these are mga similar triangles. So by interpolation, so iti-take lang natin yung ratio, i-equate lang natin yung ratio nung sides ng ating triangle. So if we're going to take the ratio of the, let's say, the vertical side, which is y1 over x1, that is equals to the ratio of the vertical side of the bigger triangle. We have y2 over x2. So itong y2, y1, x1, kukuha natin yan dito sa values natin sa normal and shear stress. So y1, itong vertical distance na to, makukuha natin siya by taking the difference of the shear stress of test 2 and test 1. So yung y1 natin ay 104. Okay? 104. Kasi yung test 2 yan. Minus yung sa test 1 para makuha yung total vertical distance natin. 71 over x1. Total horizontal distance from test number 1 to test number 2. So, subtract ulit yung normal stress naman. 150 minus 95. That is equals to y2. So, itong y2 na to, hindi pa natin alam class. But, if we have C here, okay, we can say that if test 2 has total vertical distance or vertical shear stress, which is 104, so when you subtract C, ang makukuha natin ay itong vertical distance na to. So therefore, that's 104 minus C. So 104 minus C, yung total vertical distance natin from this point, interpolate natin kung inline dito sa point kung saan in-intersect ng line natin yung value ng cohesion. Over x2, total horizontal distance. So, syempre yung test 2 yung pinakamataas, kaya normal stress ay 150. So, C na lang ang unknown. We can solve this now. So, ang goal lang naman natin talaga dito class ay hanapin yung equivalent shear stress at zero normal stress. Sige. Let's solve this. If we will directly use our calculator, we can solve that. But let's say, solve muna natin. Minus 71 over 150 minus 95, that's 0.6. 0.6 equals to 104 minus C over 150. So 150 times 0.6 is equals to 104 minus C. So 150, that's 150 times 0.6, 90. So 90 minus 104 equals to negative C. 90 negative 14, multiply both sides by negative 1, we have 14. The unit is in kilopascal. So the cohesion is 14 kilopascal. Okay? So that's how we solve the cohesion. Next one is we determine the angle of internal friction. So angle of internal friction, we can use again the value for normal and shear stress. So from that, we just determine the vertical and the horizontal distances of this right triangle formed by this line. So again lang natin class, ano ulit, tangent phi, kasi ito yung ating angle of internal friction. So, yung y natin, difference no shear stress, 104 minus 71 over 150, horizontal naman, minus 95. So, kanina, sinolve na natin yun. That's 0.6, di ba? 0.6 sa calculator. So, arc tangent of 0.6 is 30.964 okay, degrees. So that's the solution for the angle of internal friction. Ito na naman para sa cohesion. Sa cohesion, kapag merong given na 2 or more na test, so mag-interpolate na lang tayo. And para naman sa angle of internal friction, use the tangent function. Okay, so the last question is determine the shear stress at a depth 4 meters if the unit weight of the soil is 15.6 kilonewtons per cubic meter. For the last question, we have here, we will determine the shear stress at 4 meter depth given yung unit weight ng soil. So, going back sa lecture natin sa in situ stresses, ang makukuha natin kasi doon ay yung normal stress ng soil at a given depth. So, kung meron tayong 4 meters, so di ba, total stress natin ang makukuha dyan. Di naman sinabi na saturated or hindi. So, we can just simply determine the normal stress, which is the product of the unit weight of soil times the height. So, the unit weight is 15.6 kilonewtons per cubic meter multiplied by h, which is 4 meters. So, 15.6 times 15.6 times 4 is 62.4 kilopascal. Okay, so after determining the normal stress, since we already determined the cohesion and angle of internal friction, okay, we can now determine the shear stress of the soil at any point. So going back sa main general solution natin sa paghahanap ng shear strength ng soil, it is just equals to the cohesion plus sigma or the normal stress tangent phi. So yan ang general solution natin sa paghahanap ng shear strength. So C therefore is 14 kilopascal. Make sure that consistent tayo sa unit. And we have 16.4 in kilopascal also. So 62.4 kilopascal, tangent of 30.964 degrees. Okay, so the shear stress at a normal stress of 62.4 is, compute natin, 14 plus 62.4 tangent 30.964. So the answer is 51.440 kilo Pascal. So, yun class. That's the answer for the shear stress at a depth of 4 meters. So first, find the normal stress, then apply it to this solution right here. Okay, so that ends our lecture for shear stress in soil. So mainly we focus on direct shear test. So on the next lecture, I will be discussing triaxial test. So how do we solve problems which uses triaxial test? So ito kasi mga problem na to sa triaxial test, lagi siyang lumalabas sa board exam. Okay? So thank you for watching. I hope you study very hard. God bless.